You know, there's a fundamental principle of physics happening inside your body right this second with every single breath you take. It's called Boyle's Law, and believe me, once you get it, you'll start seeing it everywhere.
So think about this for a second. Have you ever played with a syringe, maybe put your finger over the tip and tried to push the plunger down? You feel that resistance, right? It gets harder and harder to push. What is that? What's actually pushing back at you?
Well, that feeling you get, that's not just some random quirk. It's you, literally feeling one of the most basic and important laws that governs how gases behave.
All right, so let's dig into that. Let's really break down what's happening inside that tiny plastic tube when you feel that pushback.
What you're doing is taking a bunch of trapped air and squeezing it. You're forcing it into a smaller and smaller space, a smaller volume. And as you shrink that space, the gas inside pushes back harder and harder. That's the pressure building up. That's the resistance you feel.
And you know what? This perfect push and pull between the space you give a gas and the pressure it creates, that's no accident. A scientist named Robert Boyle figured this all out hundreds of years ago, and his discovery is what we're going to look at right now.
So way back in 1662, this British scientist, Robert Boyle, he's the one who formally described this relationship. But he also noticed a couple of really important things, kind of like the rules of the game. For this to work, the temperature of the gas has to stay the same. And second, you can't let any gas in or out. Keep those two things constant, and the law works like a charm.
And here it is, the law itself. Now that key phrase, inversely proportional, sounds a little technical, right? But don't let it fool you. All it's really describing is a simple seesaw relationship.
Seriously, just picture a seesaw in your mind. If you push down on one side, let's call that pressure, what happens to the other side? Volume. It has to go up. And if you increase the volume, the pressure has to go down. One goes up, the other goes down. It's a perfect inverse balance.
Okay, so theory's one thing, but let's actually see this happen. We can make this super clear with a classic little thought experiment.
All right, imagine we've got a container with a piston we can move. We start with some gas inside, taking up 15 cubic centimeters of space at 1 atmosphere of pressure. Now watch this. We push that piston down and we cut the volume exactly in half, down to 7.5 cubic centimeters. So what happens to the pressure? You got it. It perfectly doubles to 2 atmospheres. It's such a clean and beautiful demonstration of the Boyle's Law. So why does that actually happen? Well, just think of the gas as a bunch of tiny little particles, all bouncing around like crazy. When you shrink their container, they have less room to roam, so they end up slamming into the walls way more often. All those extra collisions are what we measure as higher pressure. Simple as that. And because this relationship is so consistent and so predictable, you just know there's some elegant math behind it. But the best part is, the formula is surprisingly straightforward. And there it is, P1 times V1 equals P2 times V2. All this really saying is that the pressure times the volume before you make a change is always going to equal the pressure times the volume after you make a change. That product is a constant.
Let's just plug in the numbers from our piston experiment to prove it. In our initial state, we had 1 atmosphere of pressure times 15 cubic centimeters of volume, which gives us 15. Then, in our final state, we had 2 atmospheres times 7.5 cubic centimeters, which also equals 15. See? The math holds up perfectly. It proves what we saw.
Okay, but here's where it gets really amazing. This isn't just some abstract law for a science class. This is the very principle that, well, allows you to be alive right now.
Every time you inhale, your diaphragm contracts, making your lungs expand. That's a bigger volume. And what does Boyle's Law tell us? Bigger volume means lower pressure. So the air from outside, which is at a higher pressure, naturally rushes in to fill that low pressure space. Then you exhale. Your lungs get smaller, the volume decreases, the pressure inside shoots up, and the air is forced right back out. It's that simple rhythm, over and over again.
That's right. The simple act of breathing, something you do thousands of times a day without even thinking about it, is governed by this elegant, inverse relationship between pressure and volume. Pretty incredible, huh? So let's just quickly recap. The big idea here is that pressure and volume have this inverse seesaw relationship. As long as the temperature stays the same, when one goes up, the other has to come down. And this one principle explains everything from the pushback you feel in a syringe to the amazing mechanics of how we breathe.
So now that you know it's happening inside you with every breath, it kind of makes you wonder, doesn't it? Where else out in the world, in everyday life, can you spot Boyle's Law in action? Keep an eye out for it. Thanks for watching.